Hello everyone, myself Nishal Kadli. I am the technical manager for Pelf Infotech SolidWorks. So in today's webinar session, we will go through some basic capabilities and features of SolidWorks in order to reduce the time and automate your design process. So in the next here, this will be our agenda. That is, first we will go through some basic how the SolidWorks interface works and how you can customize it in order to quickly design and generate quick drawings for the manufacturing purposes. Also, we have a very interesting add-on in SolidWorks from the 2018 version that is known as the 3D interconnect. We will give you a brief detail about how the 3D interconnect works and how you can utilize it to increase the productivity of your design. Then in the next section, we will go through equation driven modeling, which will be basically related to your design intent. And the last one will be related to the SOLIDWORKS toolbox and its utilities known as the smart fasteners, how you can employ them to quickly modify your design as per your requirement. So let's get started with our agenda. So this will be the scenario. It's a simple knuckle joint. As you can see, we need to quickly design in the SolidWorks with much less steps and with much customization as possible. So let's move on to the SolidWorks software right away. This is the user interface as you can see on the screen for the SolidWorks 2019 version. Now I will start with my new part modeling. Just hit here on the new control N, select the part and OK. As you can see, on the leftmost side, we have the feature manager tree and this is the user interface. Now, as per my convenience, I like to unhide all the planes. So I will just select by shift and show all the planes. Now, my first sketch will be on the top plane. So just click on the top plane and select sketch. Now, I have customized the SolidWorks software as per my need. Some basic features and some basic sketch tools that I need frequently, I have customized them into a single shortcut. So by just pressing S, I have the display of all the possible sketch entities that are required for particular sketching. So right now my requirement is circle. So I will just click here, circle. I will specify the diameter as 150 mm. Then I will move to the next sketch setting, that is a second circle. I need to provide some relationship between these two circles in dimension terms. So I will just press S and I will go to the smart dimension. I will show it as 20 mm offset. Now in SolidWorks, we have another term. You can either go by feature boss, extrude, etc. or you can either go from the sketch tool itself. But we have an interesting tool known as Instant 3D. So it enables dragging of handles, dimension and sketches to dynamically modify features. So let's see how exactly this particular entity works. I will just click on the sketch. As you can see, an arrow mark is highlighted. If you just click and drag this arrow mark, automatically material addition process will be started. Now, as you can see, it is just unidirectional addition. I need the material to be added in both directions. So just press M on the keyboard. As you can see, now the material is extruded in both directions. So I will just select it over maybe 110, 11 something. Now let's move on to the next feature. I will select the front plane, again sketch. Again, I need to create two circles, concentric circles. I will select circle here, click 150 mm diameter, again a circle, click, place and go to the smart dimension and provide a particular offset of 20 mm. So I will just try to constrain it. As you can see, as soon as I have provided the necessary dimensions, the sketch has turned black, that is, it is fully constrained. So I will just set it 180 mm and again using the Instant 3D, I will just drag using the pointer with pressing M on both directions. Okay, this will be fine. Now I need to create some solid connecting these two vertical and horizontal cylinders. So I will start my sketching on the top plane. click sketch. Now here I will show you an interesting tool in the sketch wizard, that is dynamic mirror entities. So for that purpose I will just create some reference center line first. Using again the shortcut tool, that is by pressing S over the keyboard. You can customize those shortcuts from here. In under the options we have customize. Go to the shortcut bars, and here the flyout bar for particular environment you can assign for assembly, for part, for drawing, etc. So it will be very easy for you to access the favorite tools at your fingertips. I will go to sketch again, start dynamic mirror entities. So it will mirror entities dynamically about a specific center line. So I will click here, and as you can see it is asking me about a particular mirror line. I will select this center line and start my sketch right away. A line here from this point to this point. Again stretch it up, and I need, as you can see, as soon as I move the line, SOLIDWORKS will automatically generate the best possible references. Now my requirement is that it should be parallel with the other line. So I will just select this one and end my sketch over here. Now my requirement is I need to create a circle here, but why should I go for a sketching and increase my work? I can just project this edge over to the plane by using convert entity. Just select the convert entity, select this outer edge and hit OK. As you can see, the sketch has been converted by the reference. So if I change the boss extrude, automatically the sketch also will be updated with respect to that. Now I need to create a tangent relation between these two entities. Select these two curves, make tangent, and I will remove the extra material that I don't require. I will remove this line, and as you can see, still my sketch is little bit under constraint. So for quick constraining a particular sketch, we have fully defined sketch tool under the display relation. Select this one, select all entities, select this entire by drag and drop and calculate and hit OK. As you can see, my sketch has been fully constrained. So it does save your time if you are going for quick design modifications. Now again in the same sketch, I need to create some material removal entities. So for that purpose, I will select this point. So select this point and provide some specific dimensions. Suppose I need 115. So I will just exit. Now as you can see in this single sketch, I have two specific sketches. I need to select the particular region only. So for that purpose, I will click on the sketch entities, right click, and we have a tool known as contour selection tool. Just select this contour selection tool, and as you can see the regions are now automatically highlighted. I will select this one, drag and drop. Now again I need them in two directions. So I will just place here. Now in the next feature, I need to generate some material cut. That is, I need to remove the material using the rectangular sketch. Again I will go to the extrude cut, select the sketch and blind in both directions with OK. Now almost my part is complete, but still there are some features, like as you can see, that remains. I need to remove this particular regions. So I will just press S and we have delete face feature. Select this one, select this one and this one. In the same way, you can select these faces too. Hit OK. As you can see, my part is almost completed. Even though it might be dimensionally inaccurate, but my design intent has been completely fulfilled. So I will just create some fillet, maybe for 5 mm fillet, and I will select this edge. As you can see, SOLIDWORKS will automatically calculate the best possible edges where you can provide fillet. My requirement is all concave edges should be with fillet of 5 mm. So I will select this one, hit apply, OK. So as you can see, fillets are automatically generated using a single feature. Now my part design has been completed, but I need to create a specific grease bulb, grease fitting over the circular patch area here. So for that purpose, we have in SOLIDWORKS a design library. It works just as the pick and place mechanism, or just application of a feature over a surface by just dragging and dropping them. So under the design library, I have already created a specific feature of grease fitting force. I will just select this one, drag and drop it over the surface. As you can see, there are many configurations for this particular grease fitting. I just have to select the particular which is very suitable. I will select this one, and my first reference, that is a face, have already been fulfilled. Now my second reference is the dimension reference from the top surface. I will just select this one and hit apply. As you can see, by just one click, I have generated a grease fitting feature here, which would be very tricky if you are using a traditional method of generating plane, then generating hole, a counter bore hole, etc. So I will recommend using a design library. Now my next step is just creating a drawing. I will go to the make drawing from part or assembly. Yes, first I will save it over the desktop, maybe for webinar purpose. Knuckle joint. A drawing. Now I need an A3 sheet. Hit OK. As you can see, there are various methods of generating views. First one is the standard 3 views. Second is the model view. It will just place a singular front view, top view, or any other view that you specify. Or we have our own view palette on the rightmost corner, as you can see here. Here you will get all the views properly arranged. So my first requirement is I need to create a front view. I will just drag and drop. Now as soon as you drag and drop your first view, automatically projected view will be initiated. So just select this view and move your cursor and click. Again here, again here. So as you can see, my views are generated. So let's just I will create some basic settings here. Okay, so once the views has been generated, I need to create some detailed dimensioning and some section views of this particular part, because I need to show the grease fitting dimension. So I will go to the annotation. We have a shortcut bar in drawing 2. Here I need to create center lines. Okay, so I will just select the center line, auto insert on the selected views. You can see automatically the drawing has been generated. Now I will create for all center marks. I need to create views. I will go to the section view here. Just press S button. We have a section view. I need an aligned section view, center line, a midpoint here and here. So as you can see, a particular section which will show the alignment of the grease fitting port has been generated. Same way I will generate center line for this particular view too. And in SOLIDWORKS we have two dimensioning schemes. First one is the basic smart dimensioning, where you have to give manually a 1 by 1 dimension, or we have an automatic view of generating dimension which is known as model items. So I will just select model items, select the entire model, import the items into all views, select all the possible dimensions that I want to import and hit OK. As you can see, the dimensions have been imported properly ever since, but the dimensions are not properly aligned. So for that purpose, just select the box selection, drag and drop, and we have here a tool to auto arrange dimensions. Just click here. As you can see, the dimensions are now properly arranged in the view. Now I will just save this particular dimension drawing in a folder. See, in just few minutes we have generated the entire part modeling by reducing the number of steps, which is very important in order for the future design modification. And also we have utilized the customization as well as some design library features very effectively, which you can also implement at your design process to enhance the productivity and reduce the time. So now let's get back to our presentation. Our next point in the agenda is a 3D interconnect. So what exactly is the 3D interconnect? As you all know, our industry, which is the design industry, is a very vast, and we have lots of CAD platform available in the market. But every time, if you need to share files between your customer vendors or even between the branches which are utilizing various softwares, it becomes very difficult by converting them into step or IGS files. So SolidWorks have created a solution over it. If you have a SolidWorks CAD platform, you have the support of more than 25 plus other format files. That is, you can open an Autodesk Inventor file, a CATIA file, ProE files, even Solid Edge, Creo, NX. All the software that you can find in the market, you can directly open those native files in SolidWorks and start editing them as if they have been generated in the SolidWorks. So that is the basic capability of 3D interconnect. So let me just show you a basic part how you can convert it into the SolidWorks by using 3D interconnect. Let's get back to the software. I will close this particular file and open my 3D interconnect part file. So this is it, and I will click the open. So whenever you open a native CAD platform file in SolidWorks, there will be a green arrow over the part or assembly or even maybe a drawing file which resembles that there is a link between your native CAD platform file and the SolidWorks file. The reason we have established that link is, suppose you have two systems in your design department. One is using CATIA and another is using SolidWorks. So if the CATIA person shares a particular part which you need to apply in your assembly and you don't have to edit that, then whenever the CATIA person makes some design modification to that particular part, automatically SolidWorks will prompt you that do you want to make the changes that are taking place in the original part file. So there is always a link between these two parts. Suppose you are a person who don't want that particular link and you need to modify this part as per your requirement. So I will just click here. We have an option to break that link. I will click on the break link. Yes, break the link. Now I need to recognize the feature so that I could edit the sketches and create some modifications. So for that purpose, SolidWorks has the capability of import diagnostic and feature recognition. Before recognizing feature, you have to generate import diagnostic so that it will heal all the surface gaps, etc. Because in any CAD platform, when you export a file to any other native CAD platform file, it will generate some surface breakage and gaps which you have to clear in order to go to a next design step. So I will just right click, feature recognition. It will ask me what you want to do, automatic, standard feature, and these are the features that I want to look for. So I will just select OK. As you can see, my SolidWorks software is automatically calibrating and checking all the features. You can see the movement over the graphics interface. Now SolidWorks is checking how the part will be visualized in our CAD platform, and automatically a feature tree will be generated. As you can see on the left hand side, we have the feature tree which you can just edit as per your requirement and move on with your design modification. So it is very easy to work on the SolidWorks and also carry the design file formats, design files from any other CAD software efficiently. So this was all about the 3D interconnect. Now next one in our agenda is the equation based modeling. But before moving to that particular equation based modeling, let's see what is design intent. So design intent, as per the SolidWorks definition, is your plan to how the model should behave when it is changed. That is, the way in which the model was created will govern how it will change. If you create a very complex model with sketch dependent on one another, if you are at some stages that you need to remove, suppress or hide any particular feature, it will create problems. But using the proper design intent, that won't be issue. For example, if you model for a boss with a blind hole in it, the hole should update when the boss is moved. That is the proper design intent. If you don't create references between the boss and the hole, definitely by just movement there will be some feature errors. So an effective design intent means the model can be updated with the important factor within the design without affecting the important factor within the design, staying intact or requiring minimal updates. So in equation driven modeling, we will make use of specific sets of equations between the dimensions of the part models and using a global variable to drive them. So let's get back to the software and check how it works. Now I will open this global assembly. Click here. Okay. Now I have three basic parts. First one is this flange, second is the base, and the third one is this particular hardware, that is a pole. So what would be my design intent is that by just using one variable, I need to drive the number of poles as well as the number of hardwares in this particular assembly. So for that purpose, I need to create a specific set of equations. So let's see how those equations are generated. So my first step here will be generating a global variable. So as you can see in the tree, here in the feature manager tree, we have a folder of equations. Just right click here, manage equation. Under the global variable, you can name it anything. Suppose I will name it as screw number. Okay. So basically my value will be 10 initially. Fine. So my global variable has been set up, as you can see here, screw number. Now I need to go at the part level to create another equation which will be referencing the assembly level. So I will go to the part, edit part in context, and under this, as you can see, there is a circular pattern. I need to link this circular pattern with the global variable that I have earlier defined. So just double click here, hit equal, and just select on the assembly and click under the equation folder. As you can see, syntax has been generated, which resembles that there is an equation. I will hit OK, exit the assembly. Now this was regarding the assembly and part conjunction. Now I need to establish the equation directly at the top level so that nobody will be able to access and modify it at the part level. So I will just go here under the base, hit on the circular pattern, double click this dimension, okay. So here under the number of pattern, we have already established an equation which is at the top level. So just go to the equations, manage equation. You can see all the equations, the global variables that we have defined. You can see an equation logo has been generated in front of the dimension. Now I need to generate a pattern of this particular hardware, which I need to govern using the global variable. So I will just select this hardware, go to the circular pattern and create with 10 equi-spaced instances. Okay. Now again this local pattern is to be governed using uh, hello.
Hello.
Can you hear me?
Can you hear me?
Okay.
Okay. So
I need to regulate this.
I need to regulate the circular pattern now.
Double click on this dimension.
Double click on this dimension.
Hit equal.
Hit equal, and under the global variable, I need to set screw number.
Okay.
Okay.
Apply.
Apply.
Now once
I just
make changes
to the global variable, you can see my assembly will be updated automatically.
Suppose I need
to create 6 hardware only.
So here we have generated
an automatic relation.
So in this way
you can work on the assembly by generating equations at part and assembly level linking a single global variable to them, so that it will be very easy for you to generate rapid design modification.
So
Our next
feature here
is the SOLIDWORKS toolbar. SOLIDWORKS toolbox of fasteners.
Here
So here we have all the standards available.
we have all
We have all the standards available like ANSI, Matrix, ANSI Matrix, ISO, Japanese standards, etc. There are over 3 lakhs hardwares available, and those are always constantly updated.
suppose
Your company is your own customizing your own hardware
modification existing. We also
also
provide
modification to the existing one. We also provide you that feature.
as you can see on the right side image under
As you can see on the
the
right side image, under the toolbox library, we have insert the properties, custom properties, and you can insert your own design modification to the hardware, which can be employed for the further projects.
now
Once you have customized your hardware as per your requirement,
how you are
how you are going to employ them very fast at your assembly level.
so for that
So for that purpose, we have a very interesting tool which is known as Smart Fastener.
as you can
As you can see in the image, the toolbar just looks like this one.
suppose we have
Suppose we have a very large assembly, there are n number of holes.
design department
Design department takes almost 1 or 2 days for just hardware insertion, and then the bomb
generation is another
generation is another hectic work.
SOLIDWORKS
But SOLIDWORKS has the capability to reduce those time duration to just nearly half an hour to 1 hour.
so how
So how
can we do that?
can we do that? Let's move on to the assembly in the SOLIDWORKS. You can see I have already opened the assembly.
And
Here there are n number of holes that I need
so for that purpose
hardware.
we need to go to the design library
So for that purpose, first I need to go to the design library, go to the toolbox,
hit the adding.
and hit the adding now.
As you can see my toolbox has
As
been
you can see, my toolbox has been activated,
I will
and now
feature
I will go to the feature over the assembly tab, that is Smart Fastener.
click over the smart
Just click over the Smart Fastener.
it will
Okay.
ask you to provide
It will ask you to provide selection. That is the
surface
topmost surface of any part where you need to insert the hardware.
topmost surface
So I will select the topmost surface
over this part and
over this part, and yes, also right around here, and hit populate all. Select this one.
after you have clicked on the
After you have clicked on the populate all,
SOLIDWORKS have automatic
as you can see, SOLIDWORKS have automatically calculated
type of hole that
the type of hole that is present and generated the hardware as per the respective.
now suppose
And
we need to
now,
create
suppose I need to create some washers for this particular
et
coating, etc.
here we also have the option that
Here we also have the option that is I need to add that washer at the top stack.
you can see a washer has been
As
added.
you can see, a washer has been added here.
I need
In
to
the same way, I need to insert a top nut,
nut at
jamming nut at the bottom.
in the
I
bottom.
will select in the bottom stack, jam nut at the bottom.
As you can see, automatically
As you can see, automatically the hardware length has been modified with respect to the washers and nut.
most design
So most design department faces the problem that the length of the hardware is not adequate, etc. But if you are using SOLIDWORKS and the application of the Smart Fastener along with it,
pretty sure
I am pretty sure that those problems will be automatically eliminated from the entire design department.
so this
This was all regarding our today's webinar.
there are some
So there are some few more questions here that we would like to collect from you that
will be
will be displayed on the screen
right about
right about now.
first one.
First one,
So I have just shared you
so I have just shared you the whole question.
select the
Please select the
appropriate option so that
appropriate option so that we will be able to
check exactly what is your requirement and how.
check exactly what is your requirement and how we can employ the SOLIDWORKS very efficiently.
Now I will show
Okay.
the next.
Now I will show you the next poll question.
Sorry for the
Sorry for the noise.
you have not
If you are not voted, please
that you
ensure that you provide the proper input.
will be
So
very.
it will be very easy for us to check.
Okay.
Okay,
On to our
let's move on to our next poll question.
I will give you some.
I will give you some more seconds and then we'll move to our last question.
Okay, then
Let's move to the last question.
what are the
What are the critical challenges that you face in your day-to-day design process?
critical
Please give us proper feedback so we will definitely apply our best to increase, remove those challenges very efficiently. So this was all regarding our today's webinar, and we will definitely come back with some more advancement in our next session.
And if you
And if you have any queries regarding this webinar, we conduct
the
the information to contact has been displayed on the screen.
mail
You
us.
can either mail us or call me on the particular cell number.
Okay, then see you again. Thank you.